Okay, so what is a scale factor? Scale factor is that number that we are going to multiply by or divide by to get our second figure. Okay, so let me just see if I can better explain that. Hang on a second, let me write this down. So if you look at triangle P, and we're going this way, from this way to this way, did it get bigger or did it get smaller? It got bigger, right? So think about something. So let's look at these two sides here, the 8 and the 10, 12. So 8 times this mystery number gave me 12 because it got bigger, right? So we have to find that scale and that number, and that's our scale factor. So the same thing, how did the 6 become a 9? 6 times that mystery number also became a 9. And then we have the last one, 10 times this mystery number became a 15. But what is cool about this is because they're similar triangles, all these numbers will be the same. So how do we find that number? Well, we can set up an equation. So instead of that question mark, let me erase this, everything, and let me start with the first one. So 8 to 12. So 8 times x, right, a number, equals 12. Let's see what that x is going to be. Well, if that's 8x, divide by 8, divide by 8, and x is going to be 12 over 8, which is 1 and 4 over 8, or x equals 1.5. So if you get a calculator and you divide 12 divided by 8, you actually get 1.5. So let's see if that's true. 8 times 1.5 is 8 times 1.5 equal to 12. Do that on your calculator and you'll see that's correct. Well, let's look at the other numbers, 6 and 9. 6 times 1.5. Does that give you 9? Well, again, put that in your calculator and you'll see that's true. So that number, our scale factor here in this case, is 1.5. And the last one, 10 times 1.5. Is that equal 15? Yes, it is. So we know that the scale factor. So scale factor going this way from P to S is 1.5. Okay. Now let's look at this in a different way. What about if I went 9 to S? I'm going to go from big to small. I'm getting smaller, right? So, and then 15 to 10, and then 12. I'm going to make the error, the 12 to 8. So what would be our scale factor? Well, this one is a reduction, right? So 9 times, again, that what number gives you 6. 15 times what number equals 10. And then 12 times what number equals 8. It can't be the same number. It can't be 1.5, the number that we found before. Because if you multiply, so let's see, if you multiply 9 times 1.5, you get 13.5. So 1.5 is definitely not our number. So again, we're going to use our little equation. So actually, I'll write this over here. So 9 times, and we can call it x again. 9 times x equals 6. So we're going to divide this by 9, divide this by 9. And we're going to leave this as a fraction. X equals, and if you put in your calculator and you press simp, you're going to get 2/3. So x is going to be 2/3. Now, what I'm going to do here is I'm going to ask you to change all these to 2/3. It's 9 times 2/3, 6. It's 15 times 2/3, 10. It's 12 times 2/3, 8. And you'll see that it works out. So the scale factor going from big to small is 2/3. Okay? So how do we find the scale factor? Oh, and I guess I just did that part here at the bottom. All right, let's look at the first question here. Scale drawing. So this is a blood cell. Okay, it's a picture of your blood cell, right? But the actual blood cell, it's very tiny. It's that tiny, very, 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 very tiny. So this is the scale. They're asking, what's the scale gap going from the actual amount to the drawing? So we're going from. I guess I can. So we're going from the drawing. This is the drawing to this. So we're going to go from big to small, right? That's what we're doing, from big. So let me write this down. We're going from big too small. So what's the big number? The big number is that it's 4. And the small number is what? 8 over 1,000. So 4 times x, right? 4 times this number equals 8 over 1,000. So we're going to divide this by 4, divide this by 4. This crosses out, and x is going to be, let's see, 8 over 100. No, 1,000, sorry. 8 over 1,000 times 1/4. So the x is going to be 1 over 500 if you simplify. So the scale factor is 1 over 500. Okay. 2. This one you actually need to draw it. I would definitely draw. So the first triangle says that there's two sides that are the same. So this is 3.5, this is 3.5, and this one's 4.95 centimeters. The bigger triangle, bigger, it's the same thing. So it's 10.5 here, 10.5, and 14.85. What's the scale factor going from the smaller? So we're going to go from small to big. And to find the scale factor, you can pick any two sides. So let's pick the 490. So this corresponds to this. So the small was 495 times x equals 1485, and we gotta find out what that number is. So divide by 495, divide by 495, and x equals 3, I hope. What is that? 14.85 divided by 4.95. Yeah, x equals 3. So the scale factor is 3 because the large triangle is 3 times as large as the beginning triangle, as the first triangle, right? And we used our equation to find the scale factor. Okay. 3. So now there's a model box car and a little car, right? And that's 7 inches. And then the big car, 609 inches. So what's the scale factor from the actual length? So we're going from big to small. So we're going to go from big to small. If we're going to go from big to small, it's going to be a reduction, right? So this is a decrease. Reduction, so I got right. Reduction. So if it's a reduction, so the big one was 609 times x equals, what's the small one? Equals 7. Divide by 609. Divide by 609. So our scale factor going from big to small, can we simplify this? 609 divided by 7. Yeah, we can. So it's going to be 1 over 87. And then we have the scale for Mona's dollhouse furniture is 1 to 8. If the sofa in Mona's dollhouse 7 inches long, how long is the actual sofa? So here we have a scale, and it says that the scale factor. Now, the scale factor, the difference between scale, and you're going to ask that there are no units, but because there are no units in scale factors, the units are always the same. So we're talking about inches. So if this says actually 1 inch is to 8 inches. So that's the relationship here. Okay, so we have a dollhouse. So the sofa in the dollhouse is 7 inches. So how big is the actual sofa? So in this case, scale factor, we're going to use 8. So it's going to be 7 times 8, and that's going to give us that the actual sofa is 56 inches. So every 1 inch here in the dollhouse is actually 8 inches in the actual sofa. So that's the relationship here. Okay. All right. So in this question, what are we doing here? Side A is 2.5 centimeters. Side B is 6.25 centimeters. What's the scale factor from the first rhombus, from this one? So we're going from this to this, and you can tell that we're going from small to big. So if we're going from small to big, our number is going to definitely be greater than 1, right? Our scale factor. So let's think about it. 2.5 times a number is 6.25. So to find that number, we're going to solve the equation. Divide by 2.5. And x equals 2.5. So the scale factor is times 2.5. Why is your scale greater than 1? Because the second shape is larger than the original shape. Okay? And every time that happens, our scale factor is going to be greater than 1. So here we have an airplane, and the wing measures 20 inches. The actual wing in real life measures 20,000 inches. What's the scale factor from the drawing to the actual plane? So again, this one we're going from small to big, and it says, is the scale factor this? Do you agree or disagree? Well, let's find out. So small is 20 times a number that we don't know yet, and we'll call it x, equals 20,000. So how much bigger, right? Let's divide by 20, divide by 20. And x equals, let's cut this out, and divide by 2, what is that, 2,000? X equals 1,000. The scale factor is definitely not 1 over 1,000 because it was not a reduction, but instead it was a enlargement, right? So so the actual wing is 1,000 times bigger than the original wing. Okay, so we needed all that to explain. Okay, so VS is 3, TU is 6, and VU is 9. So I can write those numbers down. ZY is 3, ZW is 1, and XY is 2. What's the scale factor, I'm assuming they're asking? But here, the main thing is for you to make sure that you use sides that are corresponding. So make sure that whatever side you're using, it corresponds to the other side on the other side. So let's pick the easy one, the largest side. So if I want to find the scale factor, right, so we're going to go from what? Big to small. We're going to go from STU. Yeah, we're going to go from big to small. So we're going to go from the big picture to the small picture. It was a reduction. So right away, I know my number is going to be a number less than 1. So let's pick VU corresponds to ZY, right? Because this is a large side, and that's the large side, the base of the trapezoid. So the big was 9, and times a mystery number became that 3. So what was the scale factor? Divide by 9, divide by 9, and x equals 1/3. So the scale factor was that every side on the large trapezoid was multiplied by 1/3 to get its corresponding values. Okay. If the side ST measure 4. Okay, so the side ST measure 4.5. All right, so if the side ST was 4.5, and we want to change, and we wanted to see what it would measure in the smaller trapezoid, we multiplied that by 1/3, and we would get our number. So 4.5 times 1/3. Let me change that to 4.5 times 1/3. That would be 9/2 times 1/3. 3/2, or 1/1/3. So that would be the size on the smaller trapezoid. Okay. And how do you know it would be less than 1? Because it's a reduction every time. The second drawing, the second picture is smaller you know that your scale factor is going to be less than 1. Okay, so again here we have a sofa that's 15 inches. And the actual width is 115 inches. What is your scale factor from the drawing to the actual sofa? Well, obviously we're going from small to big, which means this is an enlargement. So you know our answer is going to be greater than 1. So the small is 15 times our mystery number equals the big number, 150. Divide by 15, divide by 15, and x equals 10. So our scale factor is 10, and we know that our sofa, the actual sofa, is 10 times bigger than the original. You're going to need a ruler to this, so you're going to get a ruler, and you're going to measure the distance between Toko and Point Fortins. Where's Toko? Toko is here. Point Fortins. So you're going to measure with a ruler. Okay, I have no idea what that is. And you know that's 80 miles. So you're going to measure with centimeters, and you're going to tell me how many centimeters from here to here, whether it's 1, 2, 3, and that's going to be our scale. And you can always simplify, okay? So I'll leave that up to you, or ask me when you get to this point. 11, so this one is interesting. So we have 2 hexagons. They turn the scale factor from the smaller to the larger. And we go from small to big. So we're going to go from small to big. But you're going to say, I don't have any numbers. Well, it's okay. So the larger one has a perimeter of 48. So it says that this plus this plus this plus this plus this plus this equals 48. Right? So how many sides do we have? 1, 2, 3, 4, 5, 6. So if I divide 48 divided by 6, I get that's 8. So this is 8, that's 8, that's 8, that's 8, that's 8, and that's 8. The smaller one is 12 centimeters. So this plus this plus this plus this plus this plus this is 12. So I'm going to do 12 divided by 6, and that's going to give me 2. So every side is going to be 2, 2, 2, 2, 2, 2. So again, we're going to go from small from big. So this one is easier, right? We don't even have to do the equation. What is it? Times what? Times 4. Everything's times 4, times 4, times 4, times 4. The scale factor is 4 because it's an enlargement. It got bigger. All right. Because it is an enlargement. Okay. And all sides are multiplied by 4. Scale drawing. Okay. The patio. Where's the patio? Right here. Okay. It's 5.5 by 7. Okay, so I'm going to redraw that. So 5.5, and this is 7. But in actuality, it's the actual patio is 550, right, centimeters times 700 centimeters. Notice that the units are the same, so we're trying to find scale factor. All the units have to be the same. What's the scale factor from the drawing? So what's the scale factor here? Well, this one, it's pretty easy, right? So you can see that's from small to big. What's the scale factor times 100? Okay. Oh, and then you can find the area. Let's see. So the area would be 550 times 700. 550 times 700 equals. Whew. What would be the area of the patio in the scale drawing and the area? So the area of the patio is 385,000, and the area of the drawing, 5.7 times 7 equals 385. And I'll let you figure out if there is a relationship between those two. Okay. Moving on. 12, same thing. 13, I think. So two rectangles. The area of P is 40. So this times this is 40. And the side P measures 5. And this is 40 centimeters squared. So if this is 40 centimeters squared, it has to say that this is 8, right? Because 5 times 8 is 40. So that's how I got the 8. On the other triangle, S is 1.6. And the area is 1.6. So what times 1.6 gives you 1.6? Well, it has to be 1. So that's going to be 1. Okay? So we want the scale factor from rectangle A to rectangle B. So I'm going to go from big to small. We're going to go from big to small. Let's pick let's pick the easy one, 5 and 1. So on this side is 5 times a number equals 1. Well, divide by 5, divide by 5, and what's our scale factor? Our scale factor is 1 over 5, right? Because it's a reduction, so it definitely got smaller. Okay, is that it? Yeah, and then you have your exit ticket. Okay, that's it.